Okay, so the activity that we're getting at is this. You're going to be using, if you're talking about skeletal muscles in conscious control, which part of the nervous system are we using? ANS or SNS? Okay, because what is it that the SNS controls? Your skeletal muscles, that's right. Okay, so what we're getting at here in this activity, all right, is for one, okay, so if yourself and a lab partner, if you're standing here, because you're the one with, we typically use volleyballs because it's easier to hold them and throw them as opposed to footballs. But typically, of course, what happens is the person running across in this direction, okay, is when you're throwing this ball to them, okay, you want to try to complete that maybe right in front of you. But the idea is you don't throw this ball when they're standing right here at this point. Why not? Because it's going to be behind them. So what you would want to do then, okay, is, and you'll get the idea when they're about right there. So when you throw the ball, then they've made up that distance right there, and that's the idea. So how does this tie in with the somatic nervous system? Okay, so you have to, but how are you getting that information? Exactly. So according to your chart, okay, or if you can just do this without looking at your chart, how is that information getting to the central computer or the brain? Through a specific division of the SNS. Okay, and what type of pathway is that? So when information needs to get to the brain, it's going through the afferent pathway. And when it goes, it's the effect is going through the efferent. If that's a way to help make a correlation on how to understand that, that would be correct. Okay, so this is part of the exercise that or activity that we're doing. Okay, so the sensory information is coming in through your eyes. It's going through the afferent pathway into your central computer. Then the efferent pathway is going back, not back to your eyes, but rather where? Okay, to your arm, to your arm muscles. You're speechless. Don't know what to say, or? Oh, okay. All right. Okay. So, like we said, this is one type of scenario, but how does this get more difficult for this person? There's probably two ways. Not only that, but maybe this person has to go this direction or that direction. Okay? So, and how does the central computer get better at this? Well, it's through practice. One of the things, if you want to try to maintain good brain health, okay, there's certain things that you can do, okay? And what we mean by that is we say challenge your brain, okay? So if you are walking into your bathroom, okay, you grab your toothbrush. Is it going to be in your right or left hand? Okay, so it's in your right hand. You take the toothpaste and then you up and down. Don't scrub. It's up and down, right? And what's ever in between your teeth. Typically, and it scrubs, but it doesn't get the thing, the plaque, like what you said, other pieces. Well, it is until you get into a groove of doing that. But then, like we said, if you want to, I'm not saying challenge your brain, but you said pick it up with your right hand. Maybe try doing it with the other hand. Okay? For some reason, I feel more comfortable brushing with my left arm, left hand. Okay? Mm-hmm.
Okay. Why isn't that? Like scientifically. Okay. Have you ever done the dominant eye test?
I think it's one of the things where you do this.
Go like this.
Oh. Okay.
Don't do that. Go
But
like this. Okay. Because I actually have a science question for you. So when you make a triangle, focus it in on like I'm on the star,
okay.
and right now the star is in the middle of my triangle. Now
Okay.
close one eye and see if it moves. Then open it and close the other one and see if it moves. So whichever one doesn't move, that's your dominant eye. No, hold on. It's like right now, I close my right eye and it moves. Close my left eye. Wait. Okay, now I'm confused.
Yeah.
Yeah. So anyways, whichever eye it doesn't move.
Okay. That I I don't know if that's a practical application, but part of if you're trying to determine why you're losing the sight of it or something to that effect, well, what happens is when you alter that image, eventually when it focuses in on your retina, you will lose it for just you will lose it for a brief moment in time. Because when we need to focus information on the back of our retina, we do have a blind spot. Why might that be? How does information get from the back of your eyeball to the cerebellum where it's deciphered? It has to go through what nerve? It's the optic nerve. So when that focuses in on where that optic nerve is, it can't focus on that because there's nothing there on the retina other than the track sending that back to the back of the brain. Okay, so what else might make this difficult as well is if you're standing here and your lab partner does one of these. Okay, so you have to gauge where to hit them right there. Okay, so that's the general idea of what you're going to be doing tomorrow. And if there's time, the blindfolds is more so for balance, for one. Okay, and then also here we're doing this, and two of you paying attention. We've got one drawing, one typing on the laptop, and we're all listening, right? Okay, fair enough. All right. So what you typically do in the gym, probably the large gym, is when we test this, we want to control. So what that means is you just pick a line, whether it's a volleyball line, a basketball line, one that has to run about 30 to 40 feet. The reason you do that is you, just like this tile line here, you're just walking normally, okay? You got the lights on, and you should just be looking straight ahead. You should be able to see your feet. Because what happens then is that's the control. Then what we do is shut the lights out, and then for good measure, cover your eyes with a blindfold. And then see how well you can orient yourself without sight. Okay? And through the experiences I think that I've been able to observe is towards the end of the exercise, some people get way off, or Or another control you do is with the lights on, you're walking to a specific spot in the bleachers. Lights are on, you can see and everything. Then lights off, blindfolded, and see how close you get to the other side. Well, the other side, I mean to your target area. But typically, and I think a lot of people would agree with me towards the end, well, I'm not going to give you that bit of information on how you can stay in a better straight line even when you're blindfolded and can't see. And no, it's not the force, if you know what I mean. Yeah. Okay. All right. So one of the things that we want to do is we're done talking about the cells of the nervous system. Okay, and this is a lot of what you want to know about chapter 10. Okay, and I understand it says 9 on here. If it makes you feel any better, I believe it's actually chapter 11, but I will double check. But because this, yes. Okay. Schwann cell. So what we are entering now is chapter 11, yes. So if you feel you need to do that, just cross off the top part where it says 9 and put 12 there. Okay? It just says nervous system 2, okay? Divisions of the nervous system, because what we're going to be referring to is different parts of the brain, and that's what this refers to. And a lot of these are already filled in, okay, but there are some things that we want to go over. So like I said, where it says 9-13, if you feel you need to cross that out, go ahead and put 11 on top of that instead. Okay. So, as we look at this information, okay, and if there's, I like to do a third exercise, and that is, how many of you have shot a basketball or played basketball at some point, or are going to play basketball? Okay. Okay, so let's say one of the things I like to introduce with this information is, let's say you are helping a middle school student or perhaps an elementary type. Okay? What can you tell me about this part right here? I mean, there's some you can refer to last chapter as well. You got that table. Well, it controls hormones, because your central nervous system, or your brain, it's not just your brain, it's your spinal cord as well, along with your brain stem, but we refer to, of course, your brain as the central computer. Okay? True, it's got two divisions, a central and peripheral nervous system. So, how do you know what the peripheral nervous system is? That is true, and there's a gray area involved with that, and that is the cranial nerves, okay, that are attached to the brain, that actually are part of the peripheral nervous system. And probably there's 12 cranial nerves that you will be responsible for, that you have to name in order from front to back. We haven't discussed it yet. It's this chapter though. Okay? So some of these I'm willing to bet that you have heard of. Okay? And there is an acronym that we use for that. Okay? Who knows what an acronym is? Give me an example of an acronym. No. FDA is one. The NRA is another. Yeah. Federal Deposit Insurance Corporation, FDIC, something like that. DNA? Yeah. So what is it? Deoxyribonucleic acid. Just rolls right off the tongue, don't it? Okay? So what that means is how we apply that is on old Olympic tower tips, a Finn and a German viewed a hip or a hop. Okay? On old Olympic, the 3 O's means olfactory, which is what? Your olfactory nerve, what do you think that controls? Your smell. Optic nerve probably does what? Your sight. Okay? Oculomotor. I mean, that's probably a little more, that's a little bit of both. It's your mouth is one. And some of these you need to know, are they a sensory nerve, a motor nerve, or a mixed? That means they do both, kind of like the oculomotor is a mixed nerve, I believe. Okay? So, no, it's a motor nerve. Sorry, it's not a mixed one. So what that means is vagus. Okay, that's the viewed a hop. The V is part of is what we consider the vagus nerve. The reason that's important is vagus is Latin for wanderer. Okay, the reason that the vagus nerve is named that is because as that travels, it has a terminal end. Just like an axon has a terminal end once it reaches a dendrite. So the terminal end is as that vagus nerve winds or wanders through the thoracic cavity. And what's below the thoracic cavity? Your chest, your thorax. What's below your thoracic cavity? Your abdominal cavity. So what happens is at the terminal end of the vagus nerve in the abdominal cavity is the stomach. Links up with the vagus nerve. Just brain winds its way or wanders through your thoracic and abdominal cavity. Okay, so, well, what are different parts of the brain? Well, these are your 4 parts right here. So really, you could say that's a part, and that's a part. No one would disagree with that. But it's this right here, and if you don't catch this and don't write it down, you're really going to hate yourself. Okay? Your cerebrum actually has 2 structures. Your cerebral cortex. Have you ever heard of the phrase, oh, that person is, or I am a right-brained individual, or I am a left-brained individual? Well, that's true. That controls your motor functions, but we're talking about different aspects of what makes you personality. Okay? For instance, I believe I'm more so of a left-brained individual because I like more so logic and abstract thinking, to where people who are right-brained are more into liberal arts and probably more spontaneous. Means you do something right off the spur of the moment. Okay? So if you're right-brained, you probably like English and literature better. If you're left-brained, chances are you like science and mathematics better. Okay? Now, is that totally scientifically accurate? No, not necessarily. But that's one way of looking at it. Your cerebrum, there's two cortexes, a left and a right. Your diencephalinon, yes. Just know that there's two parts to the cerebrum, a left and a right hemisphere or cortex. Okay? Because those also control all your motor functions like you just had mentioned. If you're writing with your right hand, that means that that's coming or being controlled by the left side of your body. Now, I know, I just said, didn't I say left side of your brain is controlling that right side of your body? No, no,
He
no.
didn't say left hand once.
Okay? But that doesn't mean, like, there are instances where, like, baseball is an example. That would be where someone throws with their right hand but bats on the left side of the plate. Or you could say, like in your instance, whether it's yourself or Jordan's older brother, Jess, wrote with her right hand, but when she might have been left-handed too. But some people will shoot a basketball with their left hand, but right with their right hand. Okay? There are different ways of looking at that. Now, the diencephalinon, the reason we like to throw that category in there is that controls your emotions, your hypothalamus and your thalamus. So just by hearing that terminology, which structure is on top, the thalamus or the hypothalamus? Well, that's why you got a book. Thalamus. Thalamus. And hypothalamus is the same thing, but just has a hypo in front of it. But this is the two structures. Is the hypothalamus above the thalamus or below it? The hypothalamus, is it above or below? You got a 50-50 chance. It's below. Okay? So the reason we say that controls your emotions. Okay? That makes you more so of who you are than what this does. Okay? So in other words, who can we pick on in here? The diencephalon is a structure that contains both of them, the thalamus and hypothalamus. Okay? So who can we pick on in here? Okay? So we take just part of Brock's DNA and clone Brock. Is that Brock going to be the same as this one? It can be, but why might a new Brock that's a clone be different than the Brock that we see today? Well, a little more specific. It's the experiences that you go through that would control basically who you are. At least I believe that would be more accurate. I see I'm missing an E here. The brain stem actually has 3 parts to it. Okay? A medulla on the bottom, a midbrain in the middle, and a pons on top. Okay? Medulla oblongata is on the bottom. Medulla oblongata is on the bottom. Okay? Then goes your midbrain. Now we're going from the bottom to the top. Medulla, midbrain, and the pons is actually on top. That part of the brainstem then links up in conjunction with the diencephalinon to the cerebral cortex. Okay? So we've talked about 3. Where is the cerebellum, do you think? It's in the back. Just think of like when you're ringing a bell. Like, let's say you two guys, you have a bell, so when you ring it, they say, "What do you need?" The ladies say, "What do you need?" Guys, ring your bell. Ding, 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 ding. So you go, "Sure, what do you need?" Yes. No. No. Okay. So, one of the things that we'll dive further into this later on, okay? So, now when you say lobes, that's a rather vague term. You see we got two hemispheres. We'll come back to that. But one of the things I wanted to go over, does anyone know of anybody who's had a concussion? Now we have some people who have had that now, okay? Reader's Digest likes to go through different types of segments, and this issue was Get Smarter About Your Brain. And this was if you want to call it a teenager, it says a football family lets go of a dream. Okay? The reason being is the dad here played football at Montana State, I think. Two generations of athletes. Brogan at age 11 left Mike playing for Montana State University in early 1980s. But what this article goes on to state or talk about here, I'm just going to read some different segments that I thought was very interesting. Okay? So this had happened where there's one play during a game. Brock, I think, was it two generation? Oh, Brogan. Okay, got knocked down once, and of course, I'm not saying of course, but they think he got hit in a similar manner. But after the second time he got tackled, okay, let's see here. Mike went straight for the referee, screaming. That was the second time that player had made the same illegal block. That's twice, and he's hollering at him. But another Panthers coach, Eric, noticed something more alarming. Brogan wasn't getting up. Donald rushed into the field and found the boy on his back, barely conscious. Brogan opened his eyes and looked up. "I can't see," he said. Brogan's mother, Shannon, okay, was chatting with friends in the bleachers when she heard somebody say, "I think that's Brogan." Okay, so through the trauma of going through this, I read most of the article. He doesn't lose his sight, but one of the things that I had found that was so interesting. Where was that article? Because I should have marked them, and since this is my periodical. But one of the things that happens is when players possibly go through this is what might a coach or a trainer, what's one of the first things that they might go up and ask any individual, whether it's a football player or someone who's possibly, okay, where you're at, what's your name, and possibly, well, yeah, that's true too. Well, so there's a whole variety, but probably one of the another big thing is, tell me what happened. And sometimes the answer is, I don't know. So yeah, where are you? What's your name? And do you remember what happened? And sometimes they actually can't do that. But what I had found, oh, I was on the wrong page, that's why. Okay, the following morning, Mike woke up feeling optimistic. Then a doctor arrived and asked Brogan his name. Brogan got his first name right, but couldn't remember his last name. Okay? Or why he was in the hospital. Still, after a 2-day stay, he was well enough to go home. But one of the things, you can see he's sitting here at the table interacting with his mom, and I remember reading this in an article, if I can find it.
Was that when
That's the kid. Okay. So now we see 3 weeks after his injury, Brogan was cleared to go back to school, but he could last only an hour or so a day. He sometimes flew into sudden, inexplicable rages, and Shannon mostly stopped working to care for him. Mike spent his days at the office and continued to coach the Panthers into the evening. Okay. So if you've ever known someone to have a concussion, sometimes you say, well, they're not acting like themselves. And what we just read here went into sudden and inexplicable rages. Okay? So when we talk about rage, okay, what is it that controls that in our body, do you think? We said, gosh, get a handle on this. You're what? Starts with an E. Say that again. Yeah, get a handle on your emotions. Okay? That's controlled by your thalamus and hypothalamus. Okay? That's why we want to throw that part into these structures of the brain. Because one of the aspects you'll see on this paper is going to say function 1 of 1, function 2 of, or excuse me, 2 of 4, function 3 of 4, functions 4 of 4. So, what are those specific functions that you see on that paper? Yeah, what are they? It might not be on the front page. He's going to say function 1 of 4, 2 of 4, 3 of 4, 4 of 4. Okay. When we look at the back side here, it says consciousness, function 1 of 4. Okay. Emotions, functions 3 of 4. Language, functions 2 of 4. And memory, function 4 of 4. Okay. So your cerebral cortex then has these 4 main functions. Okay? Your memory, your consciousness, which would probably include coordination too. Okay? So consciousness, memory, emotions, then finally something that you might forget. If you forget something, it means you have a bad what? Memory. That's the fourth of the 4 functions. So tomorrow, please have something that you can blind, because if you don't have something, we're going to have to put paper towels, and that's fine, but if you can see, which I think our brains put a lot of stress on sight, which for a lot of us, we're lucky to continually have that. But I mean, you're going to get more out of this if you bring something to blindfold yourself. Okay. Okay. So again, we'll pick up with that tomorrow.